Hello. This is the project for SER502. We are presenting our custom-made language called PlutoPassMercury, and we are Team 24. I am Ashang D'Souza.
And I am Pratima Singh.
And I'm Srishank Reddy.
Yes, I'm Sukanya Rani.
Yeah. So let me start the presentation. We are calling our language PlutoPassMercury, and our extension for the files will be .pm. It is a normal imperative language, and we are using Python and Prolog as to build the language. We are passing the tokens through a data structure called list, and we are marking the start and end with Mercury and Pluto. So for this language, we used Swiss Prolog for the compilation. For the tokenization and the lexical analysis, we have used in Python, Python 3, and the parts step and the evaluator step is both done by Prolog. So we start with the basic file, the .pm file, the file of our PlutoPassMercury file. That is taken by the lexical analyzer, which breaks the code, the text into tokens. The token is fed by the fed to the parser. In between the parser and the lexical analyzer, we have a token file. We're generating a token file, intermediary file. So the file will be having the tokens in each new line. So the parser will take the tokens and put it in a single list and build a parse tree. The parse tree will be evaluated by the evaluator, which is again written in Prolog. The source code is written in our custom language called PlutoPassMercury. I think I've gone through this. So I'll tell you about the basic grammar structure we are following. So a program the start of the program will be marked by the text Mercury, and Pluto will serve as the end of the program. In between that, we'll be having a list of commands, and the commands will also be having blocks. So we have these features so that we don't need to write Mercury and Pluto again and again. So we selected curly braces and close braces as our block marker. As you can see in the second last line, we can have arbitrary number of commands in our program. So I'll pass it to Sukanya, who will explain in detail about the features of the language.
Okay, so here are some features of our language. We have implemented various data types, which are int, boolean, string, floating point number. We have some evaluations, which include the arithmetic evaluations, that is addition, subtraction, multiplication, division, also the braces. Along with it, we have ternary operator. When it comes to relational operator, we have equals to, greater than, lesser than, not equals to, greater than, equals to, lesser than, equals to. Apart from that, we have commands, which are if else, for, while loop, for in range. Also, we have some statements such as the assignment statement, print statement, and the declaration statement. We have certain keywords, which are the reserved words in our language. They are int, float, bool, string, true, false, for range, pass, if, else, while, and, or, not, and so on. Also, we have certain assumptions in our language, which are that the string values which we pass as an input should be encoded in double quotation mark. The variable name should also start with a lower letter. So this is the grammar part of our programming language. As you can see that we have certain blocks here. Also, we have command list. So command list will specify that to which part of the block our control will flow. That is to the assignment part, the variable declaration part, print part, if part, for, range, while, and so on. So for every specific command, we have a grammar. For the print command, as we can see that we have a print statement here with the expression. Also for print, we have the direct printing string statement here. We have certain expressions which will calculate for addition, subtraction, multiplication, division, and so on. So we are generating a parse tree with the help of these commands. We have ternary expression as well, which will take up the condition and will evaluate the expression and thereby will display the output accordingly. We have the condition statement here. This condition statement will take up expression, has the comparison operator, and will compare it with the other expression. This condition statement is being used in while, if, for, and so on. We have variable declaration, and also we have end of command, which is a semicolon. That is the termination part of our program. So we have implemented certain more parts such as the variable type, which you can see here, the comparison operators, the data types, and so on. Now, when we see this part, we have the Boolean operation, we have the unary operation, which are increment, decrement. We have a if block here. We have a if section for this parse tree. Also, we have the condition section here. Along with that, we have the while command. So now there are certain step of execution what we are following. First of all, we'll write a source code that would be enclosed in this begin and the end part, which is Mercury and Pluto, and we'll write a normal while statement here. On executing that part, a token is being generated, as we can see here, that is while.pm.token. Now, that token is passed to this file, and a parse tree is being generated and the output is displayed. In the while condition, the output here is while is running along with the environment variable. So if you see this was the parse tree which was generated by our program. So the future scope of our project is that we can implement functions that will return a value, a dynamically typed variable instead of static types. The commands such as break, continue, and go to can also be implemented, and the various data structure like array, stack, queue can be further implemented in the project. So this was it with the presentation, and I'll pass it on to Pratima. Thank you.
So I'll start my demo with the tokenizer, which we have implemented in Python. So we have explained our tokens and reserved keywords over here, and we have this main.pl which runs the evaluator and parser. So I'll just show the run.sh, which is the compiled version of running the tokenizer as well as the parser. So here we give it Python command and we take the input file as in the argument, and same we are passing as a token file to the parser. I'll start with some of the changes or some of the implementation which we have done. Let's firstly I'll start with the for range. So I'll start with the while loop. While loop, we can see that we have done the declaration, assignment, and the while loop where it checks whether the variable is greater than 0 and then prints the thing. This is also we have implemented in our language print. It's a customized print statement. So I'll just try to run it. So firstly, it will generate the token file, which you can see that while pm.token. And while pm.token is like this, it breaks every text into the tokens, and it is passed to our main.pl file, which runs the parser and the evaluator. So if we see here, after running, it has printed the while is running command twice, and our variable x is kept as 0. I'll go ahead with the for range, where the syntax says that it's the start of the range and it's the end of the range, and this shows the step, like after one we have 2 steps, we have to move 2 steps, and so that it runs the same format. So I'll just run the for range. Similarly, if we see for range is working, for range is working, so 1, 2, and 5. I have also implemented a pass, which is just a placeholder. Like if we want to test if our program is working or not, we have just a pass just in which we do similar to the Python implementation. So when we run the pass command, it will do nothing. It will just run the file. Yep, that's it for my side. I think I'll pass it to Shashank for the rest of the demo.
Thank you, Pratima. So apart from the features which Pratima has shown, we also have more features. We have implemented if-else conditions and a ternary operator and a for loop. So in our case, if we look at the if.pm file in the data directory, we are using the same exact syntax and initializing 2 variables. X is initialized to 0 and Y has been declared. And in the if condition, you can see the syntax is similar to either C or Java. And whenever the condition is true in if, the block right after if condition would be executed. And in case the condition becomes false, the other block gets executed. So to run the command, I'll be using the command prolog. So to run it, this is the command how we would run it. swi.main.pl, we'll be calling the main.prolog file. And within the main.prolog file, we are calling the main predicate by passing in the token file as input. So as I run it, you could see the first output is the tokens of the program which we have written. And then this is a pass tree of the token. And since in our code, we are checking for a true condition, and this condition is true, the Y should be 1. We can see the final environment has Y as 1. So our code is working as expected. And similarly, we also have a ternary expression. This is similar to what you'd find even in Java or Python, but instead of a command list, we have implemented ternary operator as an expression only. So this would always return either the left-hand part of the colon or the right-hand part of the colon, depending on whether the condition is true or false. Similar to the file command which I've used for if condition, we'll be using it for ternary too. So once I run it, you can see we have an output x is -1, which is, since the condition is true, x has been subtracted, -1 has been subtracted from x and assigned to x, and we have that reflecting in our final environment. And the last feature which we have implemented is the for loop. For loop, we can see the code is, it is similar to how you would implement for in either C or Java. We are initializing the variable here with j equals to 0, and j will be incremented till 5, and for each loop we are incrementing the value of k. So if I run the for loop, we should see the k value should be 5, and we also have the j as 5. Everything is working as expected. So yeah, this is it. These are all the features which we have implemented in our language. Thank you.
Thank you.
Thank you.